Hello everyone, I'm Sudha Udaya. Welcome to today's unit in the Building and Construction Programme. Before we begin, I want to remind you of the purpose of this programme. Each unit is designed to give you the knowledge, skills and industry behaviours required to become a competent and confident building practitioner in Australia. Throughout this course, I'll be drawing on more than 30 years of hands-on experience in residential and commercial construction. My goal is to connect the theory directly to real project situations, showing you how the National Construction Code, Victorian regulations, WHS requirements, and industry standards apply on actual work sites. As we move through each topic, think about how these principles translate into the decisions builders and site managers make every day. By the end of each unit, you should feel more prepared to apply these concepts in practical, safe, and compliant ways on the job. Let's get started. Today's session is Module 3, Volume 3, Section 1, Manage Business Risk, Part 2. In Part 1, we set the foundation, risk context, scope, stakeholders, and why risk management matters in Australian construction. In Part 2, we move into the practical steps, engaging the team and pooling information, identifying and documenting risks in a risk register, analysing likelihood and consequence, evaluating and prioritising risks, selecting treatment options and building treatment plans, implementing controls, communicating the process, and monitoring results. By the end, you should be able to run a simple, consistent risk process that fits real construction projects. Team engagement and pooling information. Risk management works best when it is not done by one person in isolation. In construction, the people closest to the work often spot risks first. Team engagement means bringing supervisors, project managers, contract admins, and key subcontractors into the discussion. Pooling information from site experience, past projects, and current constraints. Encouraging early reporting of concerns without blame. Practical ways to pool information include project startup meetings and pre-commencement reviews. Toolbox talks for site-level risk input. Monthly cost to complete and program review meetings. Lessons learned from previous defects, delays, or disputes. This approach improves accuracy and buy-in because people support what they help build. Methods to identify risks. There is no single perfect way to identify risks. The best method is the one your team will actually use consistently. Common risk identification methods in construction include brainstorming with the project team and stakeholders, reviewing drawings, specifications, and construction methodology, contract and scope review, especially exclusions and assumptions, reviewing program constraints and lead times for critical items, using checklists for common risk categories, time, cost, quality, WHS, environment, contract, reviewing past project issues, defects lists, incident reports, variations, claims and disputes. The goal is to capture real risks early, before they become expensive problems. Research risks that apply to the scope. After initial identification, you research risks that are relevant to your scope. Research makes your risk register more realistic and defensible. Useful research sources include past internal project records, variation causes, defect trends, delay reasons, supplier and subcontractor feedback, capacity, lead times, pricing stability, site information, geotechnical reports, access constraints, neighbour impacts, regulatory requirements, permits, inspection gates and compliance conditions, industry guidance, common risk patterns in your project type. Business risks in construction. When building a risk register, it helps to group risks into categories so nothing important is missed. Typical business risk categories include financial, cash flow pressure, price escalation, underquoting, bad debts. Contractual, scope disputes, variation, rejection, unclear responsibilities, delivery and time, weather delays, sequencing clashes, labour shortages. Quality, rework, defects, failed inspections, non-compliance with specs. WHS, incidents, unsafe subcontractor practices, inadequate supervision. Supply chain, long lead items, unreliable suppliers, plant breakdown. Reputation, client dissatisfaction, complaints, disputes, negative outcomes. Grouping risks also helps assign the right owner to each risk. Document risks that apply to scope. Once risks are identified, they must be documented clearly. If a risk is vague, it will be hard to analyze and treat. A well-written risk statement usually includes the event or issue, the cause, the impact on objectives. For example, if waterproofing subcontractor quality is inconsistent, then leaks may occur, leading to rework, delay, and potential disputes. When documenting, keep wording practical and site-based. Avoid generic statements like quality risk with no details. Clear risk documentation becomes the foundation for scoring likelihood, consequence, and choosing treatments later. Risk register. A risk register is the main working document of the risk process. It captures risks, ratings, controls, and actions in one place. A practical risk register typically includes risk ID and description, category, time, cost, quality, WHS, etc., cause and potential impacts, existing controls already in place, likelihood rating, consequence rating, risk level, priority, treatment actions and action owner, due dates and review dates, status and notes. In construction businesses, the risk register should be simple enough to update regularly, otherwise it gets ignored and becomes outdated. Analyze risks. Risk analysis is where we decide how serious each risk is. Analysis helps focus attention and resources on what matters most. A typical approach is assess likelihood, how probable the risk is, assess consequence, how severe the impact would be, combine both to determine priority. In construction, risk analysis should consider impacts on safety outcomes, project time and milestones, cost and margin, quality and compliance, client satisfaction and reputation, contract rights, claims, and dispute exposure. The purpose is practical. You cannot treat everything at the same level, so analysis helps prioritize. Assess likelihood and probability. Likelihood is the chance the risk will occur. It can be scored using simple levels such as rare, unlikely, possible, likely, almost certain. Probability becomes more accurate when you base it on evidence such as past project performance trends, current market conditions, labor availability and supplier lead times, complexity of the work, a number of interfaces between trades, subcontractor capability and supervision strength. Likelihood scoring should be consistent across the business. If one person rates everything high and another rates everything low, you lose reliability. Seeking opinion on likelihood. Likelihood is not only a personal guess. Stakeholder opinion improves accuracy. Ways to seek opinion include supervisor input on site constraints and sequencing issues, procurement input on lead times and supplier reliability, subcontractor input on labor capacity and availability, contract admin input on variation likelihood and client behavior, management input on financial exposure and risk appetite. When collecting opinions, keep it factual. What evidence supports the rating? Document the reasoning briefly in the risk register. Use the same definitions for likely and possible across the team. This improves consistency and reduces bias in risk scoring. Assess impact or consequence. Consequence is what happens if the risk occurs. In construction, consequences often hit more than one area at the same time. Common consequence areas include safety, injury, notifiable incidents, shutdowns, time, missed milestones, extension of time disputes, cost, rework, overtime, liquidated damages exposure, quality, defects, non-compliance, failed inspections, contractual, claims rejected, disputes escalated, reputation, loss of repeat work, negative stakeholder feedback. Many businesses use consequence levels such as insignificant, minor, moderate, major, severe. Consistent consequence definitions help ensure the risk register is meaningful and comparable across projects. Evaluate and prioritize risks. Risk evaluation is deciding which risks need treatment first. This is where you compare risk levels against the business's tolerance. Typical evaluation steps include: use a likelihood impact chart to determine risk rating. Identify high and extreme risks for urgent action. Decide which risks can be accepted temporarily with monitoring. Confirm which risks must be escalated to senior management. In construction, prioritization is essential because resources are limited. The risk process should clearly show what must be treated now, what must be monitored closely, what can be treated later with planned improvements. This turns risk management into action, not just documentation. Determine treatment options. Once risks are prioritized, you select treatment options. Most treatments fall into a few common categories. Avoid, change the plan to remove the risk. Example, decline a project that exceeds capacity or risk appetite. Reduce, controls to lower likelihood or consequence. Example, stronger supervision, better inspection points, improved procurement planning. Transfer, shift risk through contracts or insurance. Example, subcontractor agreements, warranties, insurance coverage. Accept, acknowledge risk, and monitor it with contingency plans. Example, minor risks with low impact. In construction, reduction and transfer are common, but avoidance is also a valid business decision when risk is too high. Understanding treatment plans. A treatment plan is the practical who, what, when of risk controls. Without a plan, risk treatment stays as an idea. A clear treatment plan includes the selected treatment strategy, specific actions, what will be done on site or in systems, the risk owner and action owners, time frames and milestones, resources needed, people, budget, equipment, how effectiveness will be checked. In Australian construction, treatment plans should also link to existing systems like WHS procedures and inductions, quality inspection checklists, procurement and subcontractor management processes, contract admin and variation controls. This integration makes treatment realistic and sustainable. Contingency plan and cost-benefit analysis. Some risks cannot be fully eliminated, so contingency planning is essential. A contingency plan answers, if the risk occurs, what is our immediate response? Who makes decisions and who communicates? What resources are available, alternate suppliers, labour, plant over time? Cost-benefit analysis helps decide whether a treatment is worth it. For example, if a control costs $15,000 but prevents a likely $80,000 rework event, it's strong value. If a control is expensive and the risk impact is low, monitoring may be better. The aim is balanced decision-making. Spend effort where it reduces real loss, delay or compliance exposure. Action plan and implementation. To implement risk treatment successfully, you need an action plan that is tracked like any other project commitment. Implementation steps include: assign action owners and confirm responsibilities. Allocate budget or resources if needed. Update site documentation, method statements, checklists, procedures. Brief teams and subcontractors so controls are understood. Set review dates to check progress and effectiveness. Examples in construction include introducing extra inspection hold points for waterproofing, adjusting procurement timing for long lead materials, strengthening subcontractor supervision and performance checks, improving variation approval steps to protect cash flow. Implementation is where risk management becomes visible and valuable. Communicate to relevant parties. Risk management must be communicated to relevant parties so controls are followed consistently. Key stakeholders may include site teams and supervisors, project managers and contract administrators, subcontractors and suppliers, senior management, in some cases clients and consultants, Practical communication methods include pre-start meetings and site inductions, toolbox talks focused on key project risks, weekly site coordination meetings, monthly project reviews and dashboards, simple summaries, top risks and current actions. Communication should be clear and short. What the risk is, what the controls are, who is responsible, what to do if conditions change. Monitor and evaluate the risk process. Monitoring and evaluation ensures your risk process stays accurate and effective as the project changes. Monitoring includes checking whether treatment actions were completed on time, confirming controls are being used on site, not ignored, reviewing whether likelihood or consequence has changed, identifying new risks as work stages change. Risk management plan evaluation typically asks, did risk controls reduce incidents, defects, delays, or cost overruns? Were responsibilities clear and followed? Was reporting timely and useful for decision making? Did the risk register stay current and practical? Regular evaluation turns risk management into continuous improvement rather than a one-time document. Steps to evaluate a risk management plan. A simple evaluation process can follow clear steps. Review the risk register for completion and accuracy. Check whether high risks were treated and actions closed out. Compare expected outcomes with actual results. Time, cost, quality, WHS. Review incidents, defects, variations and delays for patterns. Collect stakeholder feedback, what worked and what didn't. Update the risk process, templates and controls based on lessons learned. In construction, the best evaluation point is often at key stage gates, structure complete, services rough in, pre-handover, project close out, when lessons are fresh and evidence is available. This evaluation cycle strengthens future projects and improves business performance over time. To summarize, manage business risk. At Part 2, we covered the practical stages of the risk process, engaging the team and pooling information, using methods and research to identify risks relevant to scope, documenting risks clearly in a risk register, analyzing risks by assessing likelihood and consequence, evaluating and prioritizing risks using a likelihood impact approach, selecting treatment options and creating treatment plans, including contingency and cost-benefit thinking, communicating the risk process to stakeholders and implementing controls, monitoring and evaluating the risk management plan so it stays current and effective. Risk management becomes valuable when it drives action, reducing delays, defects, disputes and compliance issues across construction projects. Don't forget, our LMS contains interactive learning video series. Please watch them as part of your study and link them to today's session. To support your study, we've introduced the AI Playbook. This tool simulates assessment questions and provides guidance. You can access it from your assessments. Thank you for joining me today. I'm Sudha Udaya, and I look forward to seeing you in the next lesson.